Hello everyone. Thanks for joining us for this late afternoon session about TikTok's journey to IPv6 only cluster with Cilium. So we're from TikTok. So I'm Joseph. Here's Giri, and we work specifically in the security engineering department at TikTok, specifically in the SRE team. So the security engineering department is a department that provides low-level security capability and services. And as part of our work as SRE, we also bootstrap and manage a Kubernetes cluster. First, let's talk a little bit about why are we using Cilium in the first place at TikTok. So a little bit of context about our infrastructure. So like I said, security engineering department, we provide the services. At TikTok, we basically have this concept of virtual data center, like VDCs. And they can be basically a public cloud machine, private cloud machine, VMs or bare metal. It's kind of a hybrid mix of a lot of things that can come from a lot of places, but they're like logically, let's say virtual data centers. It's a globally distributed multi-DC architecture. We have about 10 logical regions, and that basically represents about 130 virtual data centers. So basically, logical region are usually associated with a geographical region, but not only. So where we basically at this the layer we operate at is we have those data center team kind of providing those physical machine on-prem machine, those VMs that they source for either like public cloud or that run ourselves, and then we have the kernel ops and the kernel team basically responsible for providing images, kernel, and basically some other software like mostly related to like observability of the machines themselves. And then we run those Kubernetes clusters, bootstrap those Kubernetes clusters on top of those machines. And finally, we have our security teams that run their workload and their services on top of those Kubernetes clusters. So just to give you a rough idea of what we're talking about here. So those security services are everything related to authentication, authorization, identity management, key management, signing, encryptions. Those are relatively low-level internal services that basically are used at scale internally at TikTok and ByteDance for all the internal platforms. They're relatively low-level. They usually client connect to them via SDK, and they basically use all of basically for everything, every workload. There are a lot of basically every entities. It's a lot of gRPC, a lot of like UDP only workloads we're talking about here, and we usually front all those cluster with dual stack, so IPv4, IPv6 network load balancer. And then again, to give you like an idea of like the volume of data, the volume of data and traffic we're talking about, those clusters, like each of those clusters, do about like 300 to 400K concurrent connection, and about 20 megabytes of incoming traffic for about 10 megabytes of outgoing traffic. So you can probably more or less different load on each of those regions, but you can probably extrapolate those number time 100, and that will represent our global metrics. So due to that, we had to choose the right CNI, and we needed a powerful CNI to basically abstract away all the underlying network. Some of you might already have realized that I talk about a mix of like hybrid mix of VMs, on-prem machine, different clouds, sometimes within the same Kubernetes cluster. So we needed something to basically be able to work with those constraints. We also needed some CNI that provide high-performance networking. We're talking about a couple of million of packets per second for each of those clusters in terms of ingress. So we needed something that really work at scale, and basically we also have like relatively those security products have relatively low latency SLOs. Obviously, we also have a security team, so we kind of wanted something with like security features out of the box, but also to satisfy the SAB part of the job, we also wanted something that provides a lot of observability out of the box. And finally, a vibrant ecosystem, right? And that's why we chose Cilium. So our initial test and rollout were great. So essentially kube-proxy replacement for the high performance part, using Cilium Network Policy to provide MTLS, some other like type of network policy to control a little bit more granularly like ingress and egress traffic, and finally Hubble and Hubble UI for everything observability related. So we were quite happy about that. Something that also need to mention, which is quite interesting at TikTok and ByteDance, is we do have a flat network. So basically, each of those machines and VMs have a unique IP address globally. And here we're talking about an estate about 4 or 5 million like machines and VM all have a unique addressable IP and flat hierarchy, which is great. So it makes things really simple to think about. But that also means that for us specifically, being at this layer of the data center, we don't have any control over the network configuration. So BGP, routing, VPC peering, like all of that is done by us by the data center and like network teams. And on top of that, there's a bunch of compliance rules that some data center and some region cannot talk to each other, and so on and so on. But ultimately, this unique scheme, this unique IP scheme, means that we actually start running out of IPv4 at ByteDance. And we've been basically building, as of the past year and a half, IPv6 only data centers. And that's where it gets a little bit more complicated, because actually, when we tried, Cilium doesn't seem to work with IPv6 only data center. And this is when we were trying like Cilium 1.12. This is 2023. And, you know, we kind of tongue in check about like IPv6 here. The thing is, sometimes you can basically work around that problem, right? When you have when you can configure the network yourself, or sometimes you can, due to the nature of of what you're doing, you can probably use something like NATing or some load balancer with like dual stack load balancer to like work around the problem. But here, in our use case, IPv6 is an hard requirement. We actually had to deal with that problem like head-on. And yet, despite that, we still liked Cilium so much that we decided to invest in Cilium to make it work with IPv6 only clusters. And in the meantime, use Calico to be able to still have those IPv6 only cluster in production as a workaround, right? Now I'm going to let Giri walk through what we did to make that happen.
Thank you, Joseph. I'm now very excited to share our journey to Cilium IPv6 production in our environment. As Joseph mentioned, the company started building IPv6 only data center, which for us to start building or bootstrapping IPv6 only Kubernetes cluster. Typically, in our cluster setup, as a cluster admin, we don't have access or control over the network of the compute instances. This is a typical cluster that we have. A cluster can contain nodes from multiple different subnets, multiple different link layer domains, which we do not have control with. With this constraint, we were able to roll out Cilium in IPv4 only cluster, in dual stack IPv4, IPv6 cluster, but we were facing challenge in rolling out Istio with our IPv6 only cluster. We started our journey in trying out Cilium in IPv6 only back in 2023 when Cilium was in 1.12. So what happened when we tried out for the first time? Cilium agent crashed. The Cilium agent continuously in crash loop back off. When we take a look at the error logs of the Cilium log basically saying it's not able to detect any IPv4 address in the node, which basically we don't have, right? We run IPv6 only machines. Cilium has two routing modes. The first mode is encapsulation or tunneling mode. The second mode is native routing mode. Encapsulation mode, it's much simpler because it sort of abstract away the underlying network for us. It potentially provides larger addressing space because it doesn't depend on the underlying network limitation. However, on the other side, it provides empty overhead because of the extra headers that it needs to add. Native routing, on the other side, relies or delegates routings to the kernel subsystem. On kernel subsystems, but it needs to, the node need to be aware of the port routings at the port siders. However, the native routing mode doesn't add extra overhead. but it needs more work to configure it properly. By default, Cilium runs in encapsulation mode. So in encapsulation mode, the cluster nodes form tunnel mesh. Cilium uses UDP-based encapsulation like VXLAN and Geneve. Even though the underlying network doesn't route the port headers through encapsulation, the port connectivity between nodes could happen easily. By default, in 1.12, or I mean for the past years, Cilium doesn't support IPv6-based encapsulation. So our only option was to use native routing mode. I wish we could have access to modify the data center routings, but as a cluster admin, we don't have access to those. And the port headers are also not managed by the data center or networking team. So if we could potentially inject the port routings into the data center, it might potentially mess up our entire global flat network configurations. So this option did not work for us. The option that worked for us was cluster level BGP. So in order to make each node aware of the port headers or the port routings, we can install a BGP daemon that advertises ports across the nodes. In Cilium documentation, there's a good guide to do this using kuberouter as well as BERT to set up Cilium native routing with BGP. As a side note, these guides are now deprecated in favor of the Cilium built-in BGP control plane. At that time, we tried out the kuberouter. We were able to set it up. But it works in most cases, but in some cases it did not work for us. We started seeing packet loss, especially for the packets coming from the same node. We suspected we got hit by this issue where IPv6 NDP traffic got dropped by Cilium because Cilium incorrectly identified the packet. So back then, as we can see from the Hubble output, NDP stands for Neighbor Discovery Protocol, for your context, which is a replacement of ARP mechanism in IPv4. So Cilium incorrectly identifies the packets coming from the same node to coming from the world. In Cilium context, world here means external. So it incorrectly identifies the packet coming from external of the cluster, which makes Cilium to drop incorrectly as per the policy. This issue got fixed in 1.14. We continued our journey in trying out Cilium 1.14 last year, 2024. We verified this issue was gone, was fixed. But DNS resolution did not work. So we got hit by this issue where the L7 DNS policy doesn't work with IPv6 DNS server. In Cilium, in each of the Cilium agent, there's a DNS proxy, which intercepts DNS requests. And this DNS proxy doesn't set checksum in the UDP header, which obviously violates RFC spec of the DNS protocol, right? So the IPv6 receivers drops the response from this DNS proxy. As you can see from this Wireshark screenshot, right? It detects checksum illegal checksum, so it drops. The receivers drop the response. This got fixed in 1.15. We then continued again to try out 1.15 early this year, 2025. We ran a full test. The test results look promising. Port-to-port connectivity works fine, the same node, also for different node case. We verified the connectivity from port to external network, and then the DNS resolution worked fine. And we started experimenting more. We enabled a kube-proxy replacement flag in Cilium, which configures Cilium to also handle the service load balancing and forwarding, which fully replace kube-proxy component, right? On the kube-proxy side, they implement service handling using IP table mechanism. So in Cilium, we expect Cilium to have higher performance because of the eBPF implementation that fully replaced the need of IP tables, which is not scalable at our scale. We exposed NodePort service and tried to hit the NodePort endpoint from outside of the cluster, but the response never came back to the clients. We saw a NodePort timeout. We also ran end-to-end connectivity tests built in Cilium test suite. 50% of the test cases failed for our case, mostly related to service handling, again, the same problem, service handling and Cilium Network Policy handling. We created a detailed GitHub issue on this, NodePort timeout. If you're interested, you can take a look at the GitHub issue. But in short, the kube router that we use to set up Cilium native routing mode also use encapsulation for transporting, for the data path between nodes from different link layers. And because the tunnel interfaces from kube router are not managed by Cilium, the eBPF program in Cilium incorrectly detects the packet. Cilium IPv6 relies on the header information on the inner packet, which BPF program not able to extract. So the packet's getting dropped and Cilium not able to handle the packet correctly for our NodePort use case. Every problem that we face along this journey, we raised it in Slack, in GitHub issues. We also met few friends along the way. We went to KubeCon London and CiliumCon London. We also had detailed discussion with the maintainers. We got help from the communities. We raised feedbacks, and Cilium community is really awesome. They added a new support in the latest release to add support for tunneling over IPv6, which would solve our problems. For the past year, I think this year specifically, Cilium community and maintainers have strengthened the support for IPv6. For the last release specifically, there are two things that are highly relevant for us. They added support for IPv6 underlay encapsulation mode and kube-proxy replacement. To enable this, it's very simple. Cilium introduced a new flag called underlay protocol, which would enable support tunneling over IPv6. By default, this flag points to IPv4, but if we want to enable IPv6 tunneling, we can set this up to IPv6. Cilium 1.18 released in May 2025, we immediately tried it out in our test environment. It passed all the test cases that we had. There was a built-in, from upstream, there was a useful connectivity check test pods, which we can also use to make sure Cilium could cover all the connectivity check test cases. And we also retried the Cilium end-to-end test suite, which passed all the test cases except one, which is very specific to our environment, but we can ignore this for our use case. And we finally rolled out Cilium in production. For the first time, IPv6 only cluster in September. As per today, we have rolled out Cilium in 4 production clusters, IPv6 only. I would like to share a couple of debugging techniques that help us troubleshoot all these problems. The first tool is obviously the mighty Hubble. With Hubble Observe, we could do packet capture and also filter the traffic by resources, incoming, outgoing traffic, policy verdict. Hubble is a very powerful tool for observability and for troubleshooting. There's a handy cheat sheet that Isovalent friends created. If you're interested, you can take a look. It's very useful. The second tool, we used the Cilium CLI subcommand. There's a Cilium debug command that could help in doing lookup over the BPF maps in each of the node. The BPF maps, we could troubleshoot the contract state, the NAT table, load balancer information for various network scenarios that we ran into. However, when we ran this, it did not run in our environment. Because the Cilium CLI hard-coded IPv4 in the condition logic. So we had to patch it manually in our environment, but eventually they fixed it also upstream, so this problem no longer exists. The last tool that was helpful is PWRU, or Packet Where Are You, which is an eBPF-based network debugger tool. We use this to sort of have visualization on the kernel stack and various BPF programs that got involved on certain network scenarios. In this case, when we were debugging the NodePort timeout issue, we were able to see what are all the kernel calls that were really involved, and we understood the BPF programs. We can then took the code and read the code base and sort of have understanding on how Cilium handle packet in this scenario. Next, Joseph is going to talk about the takeaways and what are the next steps for us.
Yeah, thanks a lot, Giri. Yeah, so what's to make up of this journey, right? I think some of you might have already understood that it took a bit of time to get there. But what we want to basically show to you is as Cilium 1.18, IPv6 only cluster with tunneling is fully supported. We have multiple production deployment at TikTok with this setup. They do a relatively high load. We haven't seen any issue with them, and we're just quite happy with what we have and Cilium in general with those clusters. An important thing about this talk today is we really wanted to give this talk to put the emphasis on like working with the Cilium maintainers, the Isovalent folks, and the open source community is the reason why this feature is working today, and that working together was really awesome. A lot of back and forth. We actually met some friends along the way at KubeCon that we didn't realize who they were until we met in person. That was actually very funny. Yeah, so really putting the strength of like working in with open source software and within the open source community, even if you're working in obviously private companies. Another thing is the adoption of IPv6 is still not completely there yet. There's still quite a lot of stuff that is hard-coded and tools that you would expect should support it out of the box, yet doesn't. Yet we're working more and more to making all of us, like the entire community, working more and more to make all of our tooling and software basically working out of the box with IPv6, which is becoming more and more of a bigger, more and more common. Another thing is you probably also have noticed that this took us nearly 2 years from like the time from the first time we tried to getting Cilium those cluster production ready. But we kind of also wanted to say that sometimes some work is worth pursuing. It might be complicated, it might take some time. Obviously, that was not like a full-on active effort for 2 years, where this was kind of like a lot of like touch and go, but still kind of like pushing toward the resolution, trying all the different technique. We basically move from using encapsulation to native routing to encapsulation to try to make Cilium work for our use case. But that was a fun journey, and we're glad that it's finally working, and that everyone here can actually benefit from this work and from this work and those discussions. In general, takeaways like encapsulation and tunnel mode is a lot easier to run in the Cilium world in general than native routing, because you don't need to obviously control your networking layer. So if you're trying at Cilium, if you're trying to play with it, if you want to onboard and adopt Cilium, probably recommend trying encapsulation first. You take a performance hit in terms of like MT overhead, but in our own benchmark and in our cluster, that still provide very good performance. So you might actually get away from it. We might actually get you might be able to just run a encapsulation. And the other great thing about Cilium is Cilium is not just like one software. It's more of an ecosystem, and you can see that with all the debugging tools that are basically shipped with Cilium that really help understanding how things work, how to debug, and the fact that they're actually bundled with Cilium itself is great, and really a commitment to Cilium and the Cilium team to make Cilium very strong and robust software you can run in production. So if you have to debug something with Cilium, we would recommend starting with Hubble and Hubble UI that will probably cover most of the use case. Then moving to the connectivity end-to-end test, which is also very good at like figuring out what doesn't seem to work and what seems to be working to kind of narrow down the problem. And finally, if you need that very fine-grained information about what's going on, Cilium debug command and packet.ru are a great tool to really have an understanding of where the packets are going and why they dropped or not, So for us, the next step is now that we can standardize all of our cluster to basically use Cilium in all configuration, is obviously to like do the standardization work on our side, but also to be able to like try out some more Cilium feature like transparent encryption, some cluster mesh work, some ingress improvement, ingress, egress. But also we probably want in the future to start investigating this new Cilium BGP control plane that Giri mentioned a little bit earlier to enable native routing. It's not a massive priority for us. We're quite happy with our current setup, but that's something to consider and that we probably want to play with. And like I said, this is not a piece of work we could have done by ourselves. So we want to give some big acknowledgement first to Shubham, which is a co-worker of ours that's not working at TikTok anymore, but that did a lot of that initial work and a lot of that initial debugging. So for us, it was really important to celebrate and acknowledge people, but also all the folks at Isovanant and the Cilium maintainers, so Paul, Bill, and Julian, that really helped like helping us understand what's going on and also upstreaming all those like fixes and changes. And lately, as I mentioned a little bit earlier, when we went to CiliumCon on Monday, we went to this talk, and it turned out someone else was actually going through the exact same journey in roughly the same step. And that person is Kapi, that is present here, like, and we're going to applause. We really recommend watching the playback. It was a great talk, and the use case was a little bit different. It was like, but kind of similar, right? IPv6 only cluster, but this time with native routing because they had access to like the underlying like network configuration. So, but it's a great talk and it's quite complementary to what we did here in terms of like our talk about like tunneling and encapsulation, and this is more like if you want to see on IPv6 only with native routing. And yeah, that's about it. I don't know where we are for time. I think we have a few minutes left. So if you have any questions, yeah, feel free to go ahead.
Yeah, we have 2 minutes. Others.
Hi, thank you for the talk. I had a question about access control lists in this setup. How do you implement them? How do you update them? Like if I want to block a certain range of IPv6 addresses from access, how would I address that?
The question is, how do we want to perform access control lists with Cilium, right?
Yep.
And Cilium, they have a Cilium Network Policy. With Cilium Network Policy, you can do any kind of control that you want, either at L4 or I think L3 IP base also work.
Yeah.
I think, and then to the L7. I think it's because of BPS program, right? It would know all the things happen at the kernel space, so they can control, I think, everything.
Yeah, we're not massive user of network policy, so but yeah, that should be covered
in the next step.
Yeah.
Great talk, thank you. This is more of a organizational question, but how did you go about convincing management that working on IPv6 for 2 years and through the open source community was like worth it? I think my management would be like, give up, buy something. I don't know. Any advice there?
Yeah, so the question is like, how do we manage? Yeah, how do we get the buy-in for continuing using Cilium, despite the fact it was actually not working for some of the environment and use cases? That's a great question. I think the reason why it worked for us is like we were already using Calico to begin with, so technically the fallback was not exactly a fallback. It was already let's say the old setup. However, there was a real business impact, right? Those Calico cluster tend to have like a much higher latency than the Cilium cluster, and didn't scale as well. So we basically managed to, so we had ways to make it more palatable, basically by like switching more and more of the traffic to those new Cilium cluster, to basically not to entirely deprecate the one still using Calico, the IPv6 only one. But yeah, so for us it was worth it, and it was a good technical solution. And also we keep seeing improvement along the way, right? We're not completely blocked. But yeah, we're also very grateful to have like the opportunity and the freedom to continue this work.
Hey, thanks for this wonderful session. I just have a question regarding like size of the cluster. So what is the maximum number of nodes that you have where you have implemented this IPv6 cluster?
Yeah, so the question is like, how many nodes do we have in those community cluster?
Yeah.
Well, not a whole lot. I would say like quite a few of them are just like 50 nodes per se. However, they're very, very, very big machines. They tend to be like massive, like bare metal machine, 256 core, like very few terabytes of memory. So they quite large workloads in terms of like pods are quite large and do under a lot of connection per pods. But we have also a lot of pods per cluster. So it's not that much the complexity is not on the node level. It's more like on the workloads themselves.
Okay. And what is the main driving factor why you choose this IPv6? Is it due to security, or like what is the driving factor to choose IPv6 only cluster?
Sorry, can you repeat? I didn't catch the beginning of the question.
Why you choose IPv6 only cluster? Like what is the driving factor for that architectural decision?
Well, the driving factor. Okay, so the question is like why are we using IPv6? We decided to go with IPv6 only clusters. Like we mentioned at the beginning of the talk, we basically BadDance kind of is running out of IPv4 addresses, and also we're growing at a scale at a very exponential scale. So we're using more and more IP addresses in general, and we're building more data centers and deploying more and more stuff and growing as a company, kind of very crazy fashion. So that was going to be a problem very quickly. So lack of IPv4.
I think the time is up. We'll stick around. We can talk. Thank you.